the last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hello everyone, you're welcome to mathematics class. I'm going to be taking through the topic trigonometry. As you all know that trigonometry comprises of so many subtopics, where it comprises of, if we are talking about the trigonometrical graph, if we're talking about reducing an angles, talking about angle of elevation and depression, talking about bearing and distance. But today I'm going to be discussing on how we can be calculating the angle of elevation and depression, and as well distance and bearing. But before we go into the deep calculation, there are some formulas that are involved whenever we want to calculate anything that involves bearing and distance or angle of elevation and depression. And the formulas include the Pythagoras theorem, the sine rule, and the cosine rule. So now, if we're talking about the Pythagoras theorem, in a right angle triangle, the side that faces the right angle, if I'm talking about right angle, I mean the angle 90 degree, is what we call the hypotenuse side. And the relationship between the hypotenuse side and the remaining two sides is what the Pythagoras theorem is just all about. That's the reason why in Pythagoras theorem it has to do with what? It states that the hypotenuse squared equal to the sum, the square of the sum of the opposite and the square of what? The adjacent, which is what we call Pythagoras theorem. If we take note of a right angle triangle which has a side C being the hypotenuse side, because this is the right angle triangle that is facing the hypotenuse side. The angle C is the hypotenuse. So let's assume if an angle formed here, the angle that formed, based that it is facing this side, will make this side B to be the opposite. But if the angle formed at this point and is facing this side, we also make this side to be opposite. But in as much as we are making use of this side, that's the angle formed at this point, that simply means our A will be the opposite side. That's the reason why the Pythagoras theorem here, based on this right angle triangle, is the hypotenuse squared, which is C squared, equal to A squared, which is the opposite squared, plus B squared, which is the adjacent squared. So that in any calculation that you are looking for one of the side, if it is basically based on the right angle triangle, that means you have to make use of the Pythagoras theorem. Now, that is the reason why the equation C squared equal to A squared plus B squared is used to solve for one side of a right angle triangle when other two sides are given. Now, let's assume you have to look for the opposite side. It's just for you to make use of the A squared, which is the opposite side, as the subject of the relation, which will now give you A squared equal to C squared, which is the hypotenuse squared, minus B squared, because you are going to transfer the plus B squared across the equality sign to go and meet the C squared, and by the time plus is crossing the equality sign, it's going to turn to minus. That's the reason why the opposite, if you're looking for the opposite side, is going to give you A squared equal to C squared minus B squared. And likewise, if you're looking for the adjacent side, it's going to be B squared equal to C squared minus A squared. Now, let's go to the sine formula. Whenever we are talking about sine formula, because it's very, very common whenever you want to calculate. Maybe we're talking about the angle of elevation and depression, or bearing and distance. You are going to make use of this. And you know that in sine formula, the consideration is being given to other triangles. It may be scaling, it may be right angle triangle. The consideration is given to different triangles. It may be equilateral triangle, but the consideration is majorly given into other triangle, right, more than this right angle triangle. So as usual, the angle of any triangle shall be denoted with the capital letters, and while the side opposite facing this angle shall be respectively named A, the side A, the side B, and the side C. So the basic things about this sine formula is that the sides are proportional to the sides of the opposite angle of them. Now, for us to generate the sine formula, we normally look at two different cases, and this will be examined. Will be examined to derive the sine formula. And what are those two cases? That is the acute angle triangle and the obtuse angle triangle. Looking at this triangle, you know that we have this capital letter A, B, and C. This capital letter A signifies the angle A. The B signifies the angle B, while the C signifies the angle C. So where our A is facing, which is this side, is the side A. And where the angle C is facing, which is this side, is the side C. And where the angle B is facing, which is this side, is the side B. Don't let us forget, if there exists a perpendicular line up to this point, and we tag this place as D, so which simply means from angle A, B, and C, we draw a perpendicular line to this point to be, we call this place D, that is to the line BC. Line BC is our horizontal line. Now, in triangle ABD, if this is D, the triangle ABD, this is our triangle ABD, okay, we can, if you look at this triangle ABD, this line AD is common to triangle ACD. So which means AD is common to triangle ABD and is common to triangle ACD. Now, what are we looking for? You know, we are talking about acute triangle. We are looking at sine formula from acute triangle. This angle that formed here is an acute triangle. The angle that formed there is an acute triangle, and likewise the angle that formed at this A is an acute triangle. What is an acute triangle? An acute triangle is an angle that is less than 90 degrees. It is less than 90 degrees. That is not up to 90 degrees. Now, if we now look at this triangle ABD, if we make use of the word SOHCAHTOA, where the SO is, that is sine equal to opposite over hypotenuse, the SO opposite over hypotenuse, the CA adjacent over hypotenuse, and the TOA, that is opposite over adjacent. If you look at this, we are considering this angle B is facing the opposite side, which is line AD. That simply means sine B will give us the opposite, which is line AD, over the hypotenuse, which is C. So if we are to cross multiply based on this, if we are to cross multiply, that means our AD will be equal to C sine B. Let's make that equation 1. You know that it was rightly said that line AD is common to both angle ABD and angle ACD. Now, if you look at it at the other side, that is this angle C, that simply means it's facing line AD as well. So which simply means sine C, which is what we have here, will equal to line AD over the B, which is the hypotenuse side. So if we cross multiply as well, we're going to be having AD equal to B sine C. That should be our equation 2. We know that in equation 1, AD is equal to C sine B, and in equation 2, AD is equal to B sine C. Now, why can't we equate both two equations together? So if we equate it together, that means AD is equal to AD. Likewise, C sine B is equal to B sine C. which is what is being written here. C sine B is equal to B sine C. Now, if we look at it, if we bring our B to this point, and we bring our C to this point, that means we're going to have sine B over B equal to sine C over C. Also, if we bring the sides, we collate it together at one point, and we bring the angle at one point, that means sine B over sine C will be equal to B over C. That is what we have here. That is why what we have here implies what is happening here. Similarly, that means since this one can give us what we have here, which is that is sine B over B to be equal to sine C over C, that simply means sine A over sine B can also give us A over B, and it also implies that sine A over A will equal to sine B over B, and sine A over C equal to A over C, which implies sine A over B also equal to sine C over C. That is the reason why we deduce that if we combine everything together, we have sine A over A equal to sine B over B, which is equal to sine C over C. Or all the sides can be as the numerator, while the angles will be as the denominator. That is A over sine A equal to B over sine B, which is equal to C over sine C. Now, that is, we look at it from the acute angle. Now, let us look at it from the obtuse angle, that is the sine formula. If we have this obtuse angle, what is an obtuse angle? An obtuse angle is an angle that is more than 90 degrees. It's not equal to 180 degrees, but it is more than 90 degrees. So the angle that formed at this angle C is what we call an obtuse angle. Now, we have two triangles here. We have triangle ABD and we have triangle ACD. Now, in the triangle ABD, if we are to make use of what? Of SOHCAHTOA, the angle that formed here is facing the opposite side of line AD. And the angle that formed at C is also facing the opposite side of line AD, which means line AD is common to both triangle ABD and triangle ACD. Now, let's look at in triangle ABD. You know that our sine B is going to be what? Opposite, which is line AD, over the hypotenuse, which is C, which is what we have here. AD over C. If we cross multiply, we also have AD equal to C sine B. And that is our equation 1. If you look at the triangle ACD, that simply means we have, if this is an angle that is opposite over the hypotenuse. And what is the hypotenuse? That is our side B. That simply means line AD, that is from this triangle ACD, that simply means our line AD, which is sine C, will now give us AD over B. So if we cross multiply, that simply means our AD will be B sine C. Then if we put both equations together, we're going to be having C sine B equal to B sine C. That simply means this equation 1 and equation 2. AD is equal to AD, C sine B is equal to B sine C. So that is what we equate together. And then if you look at it, sine B over sine C is also equal to B over C, which is similarly sine A over sine B is also A over B, and sine A over sine C is A over C. So therefore, if we combine all these results together, we also have sine A over A equal to sine B over B, which equals to sine C over C. Or if you interchange it, that means the side is at the numerator and the angles is at the denominator. That is A over sine A equal to B over sine B equal to C over sine C. So that is looking at it from the obtuse angle side. Now, you should note that the formula is used to solve problem connected with any triangle, where most especially either, let's say, we look at two ways, that is two angles. In other words, all the three angles on one side. That is, if two angles is being given and one side, that means you can use sine formula. Or if two sides and the angle opposite to one of the side is being given, yes, you can make use of sine formula. So thank you for listening.